Let's talk about supersaturation. Supersaturation is defined as the ratio of the activity product in a given system to the equilibrium solubility product of that system. Okay, so we've got the activity product under given conditions. Under given conditions, so that's the solution you essentially have in your hand at the time. Okay, and then this is the activity product at equilibrium. Okay, remember the activity product at equilibrium, we call that the solubility product. Okay, so at equilibrium, this is going to equal 1. Okay, because the activity product of your given solution is going to be the same as your activity product at equilibrium. Okay, so supersaturation at equilibrium is equal to 1. Okay, so supersaturation in a saturated solution is 1. If supersaturation goes above 1, then material will precipitate from the solution. Supersaturation basically indicates how much a solution is out of equilibrium. Okay, so if you imagine you've got a solution, you can make it. You can go above the saturation point by a little bit. Your supersaturation will be small, or you can go above that saturation level by quite a lot. Dump loads of ions in that solution, and then it's going to be high. That's illustrated by these pictures. Here we are. We've got a supersaturation of 1, and we're at equilibrium. Okay, so our solution is saturated. If we have a low supersaturation, so we've just got a few more ions than we should do to be at equilibrium, our supersaturation is above 1, and there will be a driving force towards precipitation. But if we dump loads of ions in that solution, so the difference between this solution and equilibrium is much, much higher, there's going to be a really big driving force for precipitation. Our supersaturation is very much higher than 1. Okay, so at high supersaturation, there's a big driving force for precipitation to get that solution, to get that system back to equilibrium. And we can define something else as well. That's this difference in chemical potential. We call this a thermodynamic, essentially, driving force towards precipitation. So it's the difference in chemical potential between a supersaturated solution and a solution that is in equilibrium with the solid. So most of these things are familiar. You've got the difference in the chemical potential. We've got our Boltzmann constant. T is the temperature, and then we've got ln S. S in this case is not entropy. This is supersaturation.